After the genus Homo had sprung from the australopithecine apes out on the plains of East Africa in the Late Pliocene, our earliest ancestors began to spread out across what would one day become the nation of Kenya. Homo rudolfensis, habilis, and eventually erectus would be among the earliest of our ancestors to take this leap, first spreading out across Africa and eventually Eurasia. They were not alone, though. From the australopithecines that gave rise to our ancestors, another genus appeared on the grasslands just under 3 million years ago. Paranthropus, near man. These apes did not just resemble australopithecines, however. They were australopithecines. Paranthropus's 3 known species, Ethiopicus, robustus, and boisei, were hominids, but one could argue, not human. More closely resembling the members of the genus Australopithecus, from which they were descended than us, these apes shared Africa with our earliest ancestors for almost 2 million years, and have left behind much for our generation's scientists to learn. In today's video, we will be attempting to collate these findings to better understand the 3 confirmed Paranthropus species. We will be traveling back to Pliocene and Pleistocene Africa to find out what these apes looked like, how they lived, and how they may have interacted with the early humans that shared the plains with them. Before we get into the differences and characteristics between the known species within this genus, it's important to note that Paranthropus's validity amongst hominid genera is on rocky ground. Some paleontologists and anthropologists argue that due to the unique traits shared by the skeletons of the species assigned to Paranthropus, it is sensible to group all of these animals under the same heading. Others, however, argue that the similarities between the known Paranthropus species are down to convergent evolution, the process by which 2 distantly related or unrelated organisms evolve the same physiological features in response to a shared ecological niche or habitat. A good confirmed example of this process are the similarities in body plans within sharks, dolphins, and the ichthyosaurs, extinct reptiles that swam in Earth's oceans when the dinosaurs were alive. These animals all have long, streamlined bodies, prominent dorsal fins, and broad tails to help them pursue fish through the water with ease, yet are not closely related. The same, some scientists argue, may have happened in Paranthropus. Those who reject the idea of Paranthropus as a valid genus question whether some specimens belong to species of Australopithecus, or if they may belong to a new genus entirely. Moreover, Paranthropus fossils are generally few and far between. Despite the important information scientists have been able to discern from the specimens they have collected, the remains of these apes are often fragmentary or sparse. Still, as Paranthropus's validity is currently under question and has not been concretely proved or disproved either way, let's operate under the idea that Paranthropus is valid for the purposes of grouping these fossils together and covering them in this video. It is just as likely that the genus will remain valid as it is that it will become invalid at this time. Paranthropus robustus was the first species of this genus to be named and described when Scottish South African paleontologist Robert Broom established this ape's fossils as being distinct from both Australopithecus and Homo in 1938. The remains were actually unearthed by a schoolboy from Pretoria, South Africa, who happened across a brain case belonging to a male hominin around 70 kilometers southwest of the city. 10 years later, in 1948, the Swartkrans Cave, in roughly the same fossil site, Kromdraai, would prove fruitful in revealing more about this species. Robert Broom, together with fellow South African paleontologist John Talbot Robinson, would encounter a jaw belonging to a juvenile also belonging to Paranthropus. It wasn't immediately clear that this was specifically a Paranthropus robustus jaw, however. The scientists initially assigned the find to a new species, P. crassidens, believing them to be distinct from those they had found 10 years earlier. It has since been determined that there are not enough differences between the two populations, and both of these South African finds belong to the species Paranthropus robustus. Then, in 1959, the accomplished British paleoanthropologist Mary Leakey would make a huge discovery in Tanzania's Olduvai Gorge. Working closely with her husband Louis Leakey, the couple are famous for publicizing the idea that humans originated in Africa and discovered and described various specimens of ancient hominin. This find, a skull lodged in a gully belonging to an adolescent male hominin, would be one of the most notable of her career. Taking measures to protect the find from weathering before excavating it from the ground, Mary nicknamed the find Dear Boy, while Lewis suggested that the skull belonged to a genus distinct from Paranthropus, Australopithecus, and Homo. He proposed that a new genus, Zinjanthropus, Zinj being an old Arabic word for coastal Africa, should be established with this as the type species. Lewis's proposal was rejected ahead of the 4th Pan-African Congress on Prehistory. However, as it was based only on a sole specimen, that's not enough fossil content to reliably establish a new genus. This specimen would soon find itself in the genus Australopithecus, following the discovery of a lower jaw belonging to the same species, and the name Australopithecus boisei was given to it, with boisei honouring Charles Watson Boise, the benefactor funding the Leakey's excavations. Over time, more fossil content belonging to boisei was found, which indicated that this species had a closer relationship with Robert Broom's Paranthropus. As such, it was later reassigned as Paranthropus boisei. It remains the most well-known and publicly famous of the Paranthropus species to date. For a while, it would seem that key Paranthropus discoveries took place every 10 years or so, as the next species would be established in 1968. This time, it was French paleontologists Camille Arenbourg and Yves Coppens that unearthed a mandible, void of teeth, from the Shungura Formation of Ethiopia. Again, this specimen didn't immediately get assigned to Paranthropus, and instead briefly became Para-Australopithecus ethiopicus. In 1976, Francis Clark Howell, alongside Yves Coppens, re-examined the find and assigned it to Australopithecus africanus. It wasn't until 1986 that Alan Walker and Richard Leakey, the latter being the son of Mary and Louis, placed the find within Paranthropus as Paranthropus ethiopicus. Of the 3 species, this one is the least certain to remain a member of Paranthropus due to the adaptations possessed by its subsequently found teeth. They seem to have distinct morphological differences that may not have been suited to the herbivorous diets enjoyed by other members of Paranthropus. For the Homo habilis, rudolfensis and erectus that came face to face with the varying species of Paranthropus, it would have been clear that they were notably different species. The first notable difference, visible especially to the later Homo erectus, would have been that Paranthropus species were most likely covered in fur-like body hair, similar to the hominins in the genus Australopithecus. Male Paranthropus across all 3 species were larger than the females, but generally speaking, their bodies were no larger than Homo erectus, with males standing roughly 4.5 feet tall and females measuring just under 4 feet. Adults would have been visibly sexually dimorphic. This is an evolutionary process where male and female animals look different to one another in terms of size or shape. This is a feature seen in several modern-day apes, most notably in gorillas and orangutans. The biggest differences between our earliest ancestors and Paranthropus, however, were all in the face and skull. Unlike members of the genus Homo, Paranthropus species each had what is known as a sagittal crest running along the top of its skull. These ridges of bone, which are seen in the skulls of modern-day gorillas, would have been anchoring points for immensely strong muscles that would have helped these apes chew the tough vegetation they consumed. These adaptations carried down to the jaws, where robust hinges allowed these hominins to grind their food from side to side, rather than up and down. The roofs of their mouths were strong and reinforced, a byproduct of the evolution of their broad, robust faces, and their teeth were covered in very thick enamel, which would have helped them chew abrasive food matter without causing wear and tear damage on their molars. At a glance, these apes would have had wide plate-shaped faces caused by their protruding cheekbones. Their eyes were small and centered within the animal's face, set below a protruding brow ridge and above broad nostrils that resembled those seen in a chimpanzee. There were notable differences between Paranthropus species, however. Paranthropus boisei's limbs were typically more robust than those of the other two species, which may indicate that it still spent time hanging or swinging from the trees. The teeth of Paranthropus ethiopicus seem to have developed faster than those of its contemporaries, while Paranthropus robustus seems to have smaller joints and more gracile limbs than Boisei and Ethiopicus. All three of these species, then, seem to be suited to various lifestyles and niches within similar environments. All of them would have been primarily bipedal, but may have exploited different food sources, and some species may have spent more time in the trees than others. There are no living apes similar to Paranthropus, which can make it hard for researchers to determine exactly how these primates may have lived. That being said, proposals and theories have been put forward regarding the high degree of sexual dimorphism seen between males and females within the three species. In modern great apes, sexual dimorphism, where the males are larger than the females, indicate that troops are often led by a dominant male, for example, a silverback gorilla. It has been suggested that Paranthropus likely lived in family groups, led by a single male, who had control over his contemporaries and mating rights with the females of the group. Older males, being more well-built and robust, likely had the most powerful positions in Paranthropus groups, and may have been challenged by rivals for leadership on occasion. This idea has been challenged, however, by studies showing that Paranthropus females may have left their family to join a mate's group when they reach maturity. This would imply that males did not have free rein over their group's females. It is thought that maturity may have been reached between the ages of 12 to 18, at which point a female would have travelled away from her homeland to start a family. Babies are thought to have been born every 40 to 70 months, depending on the species. While there were differences and preferences between the individual species of Paranthropus as to where and how they lived, they generally seem to have preferred woodlands along Africa's Great Rift Valley. Paranthropus robustus seems to have favoured slightly more open environments, while Paranthropus boisei seems to have lived in close proximity to more dense regions. As is the case with many mammal species, there would have been a degree of overlap in where species ventured to and where they could be found. And along the Rift Valley, Paranthropus was probably a frequent visitor of wetlands, the banks of lakes, riverine environments, and shrublands. Throughout these environments, there were a great deal of food sources available to Paranthropus. While the teeth and jaws possessed obvious adaptations to feeding on tough, starchy foods, it is thought that softer substances were preferred where they were available. Primarily, Paranthropus seems to have been a strict herbivore, with teeth adapted to chewing through all manner of plants, including seeds, tubers, and various species of grasses. Paranthropus communities living in the southern reaches of Africa appear to have been omnivorous, opportunistically adding meat and insects to their diet. Across their range, tubers seem to have been the most widespread and favoured food amongst Paranthropus species. Juvenile apes seem to have been particularly fond of them, as evidenced by the wear on their teeth. Foraging would have made up a large part of Paranthropus's life, spending over 6 hours a day digging for tubers and searching for suitable grasses. Despite not technically being a human itself, Paranthropus is known to have made and used basic tools to help make foraging and feeding easier. In Western Kenya, tools have been found alongside the teeth of Paranthropus in the form of basic, broad stones that would have been used to smash open tough vegetation or to carve larger rocks into handheld shapes and sizes. While these date back to around 2.5 million years ago, much more recent examples have been found in the South African caves that have yielded many excellent Paranthropus finds. Roughly 600,000 years old are effectively multi-purpose tools made from rib bones, jaws, and horns of hoofed animals. These objects show very little wear and tear and appear to have been hand-picked, as many of them look very similar. These have been attributed to Paranthropus, as no Homo fossils have been found within these caves as of yet. The apes may have been using these tools to cut their food into manageable pieces, or they may have been used to probe through soft soil in search of roots and tubers. There is no evidence that Paranthropus had the ability to craft advanced tools, such as spearheads or points, and they did not have the means of creating and controlling fire. The tools they did have suited them well, as they did not rely upon hunting, but spent much of their time searching for plant matter within forested regions. Like our earliest ancestors, Paranthropus would have fallen prey to a wide range of deadly predators, both in the forests and savanna. Saber-toothed cats, such as Dinophilis and Meganterion, would have been deadly ambush hunters capable of pouncing upon foraging Paranthropus when they let their guard down. Elsewhere, modern-day leopards would have been able to pursue these apes up trees, rendering few places truly safe from attack. Hyenas would have been a widespread threat in open areas, while crocodiles, such as the extinct Crocodylus anthropophagus, literally man-eating crocodile, would have lain in wait when the apes came down to lakes and rivers to drink. It would seem that male Paranthropus had higher chances of meeting violent fates than females. This has been explained by the idea that male Paranthropus were more likely to be ejected from family groups, perhaps after leadership challenges. On their own, they were unlikely to make it very far in a world with so many large apex predators. In this evocative painting by artist J. Matiness, featured in the Time Life Early Man book, a group of early humans can be seen entering a violent combat scenario with a group of much more primitive-looking, almost Bigfoot-like Paranthropus. The hominins on the left wield carved points and appear to be winning the battle, as many of the background Paranthropus flee the scene, while a few determined boulder-wielding apes stand their ground. It's certainly a very well put-together piece of art that depicts an encounter that very may well have taken place, but it's unknown just how common such a meeting between species might have been. We know that Paranthropus did coexist across several species, with members of the genus Homo from Kenya to South Africa. But whether or not this coexistence led to violent encounters remains to be seen. In Kenya, footprints belonging to both Homo erectus and Paranthropus boisei have been found in very close proximity, indicating that these species likely crossed paths on more than one occasion. These species, however, competed for very different resources. Homo erectus used skillfully carved stone points to attack and kill prey animals out on the African plains, while Paranthropus was more or less a strict vegetarian. Competition was limited, especially considering that Paranthropus tended to stick to forested regions. However, the possibility of violence can never be ruled out, especially when we're talking about human beings living in an unpredictable and dangerous time in Earth's history. Perhaps the two species in some areas came into competition over the same plant-based food sources, or maybe there were disputes over cave space or territory. As Homo erectus became more populous and began to spread out over the African continent, interactions would have been more and more common. Perhaps Paranthropus saw the encroaching Homo erectus as a threat in some scenarios. Until we have solid evidence to suggest either way, we may never know. But it seems that, for the most part, Paranthropus were not a violent species by any means. Sadly, Paranthropus did not make it into the latest stages of the Pleistocene, and the genus disappeared from our world around 1.4 million years ago. A leading factor as to why this happened may lie within us, inadvertently at least. Our Homo erectus ancestors were much more well adapted for a life outside the restricted African forests, and soon found themselves spreading out across much of South Asia. Paranthropus, unable to make advanced stone tools or exploit a wide range of food sources, likely died out as Homo erectus spread across the ancient world. They may also have been unable to cope with the spread of grasslands around 1.5 million years ago, which slowly saw their woodland homes begin to retreat. This would have brought them into competition with grassland species such as baboons and grazing herbivores, which, given their loss of habitat and specialized diets, would have been an uphill struggle. With the loss of Paranthropus from our world, Homo became the only genus of upright walking hominin on planet Earth. What came next were millennia of evolution and expansion, speciation and extinction. The world was changing at a quicker pace than humans had ever seen, and the onset of the Ice Age would leave the world of Paranthropus, sadly, in the dust.